your book out if you have one, and your notebook, because we're going to get started. Anyone have any questions about anything? Okay, I covered everything so well that y'all don't have to worry about it. Okay, let's go back to our handy-dandy ebook. Somebody tell me that's got a syllabus where I told you to put it real handy. What chapter do we go in first? I don't know if they rewrote the syllabus, that's why I'm asking. Chapter 1, okay. Alrighty, so textbook, chapter contents, chapter 1. Let's go through and look and see what's important, because that's what I always do with students. I always, what sections do we cover? Does it 1.1 through what? I mean, does it skip around or is it straight through? Straight through? Huh?
Yes, 1.4 and then 2.1 and 2.4.
And then that's unit 1? All right, well, let's start at 1.1, and I will show you. We're going to go through all the way through, so you might want to take a sheet of paper in your notebook and put weights, because we're going to put weights, and I'm going to tell you how weighted section is, and that way you'll know. Domain and range, important. Just put domain and range, important. Recognizing functions. Don't worry, I'll write them on the board. Vertical line test. This is taking too long. All right, get your syllabus. Out of chapter 1, you're talking 20%, 20%, 20%, and 40%. If I gave you a test on chapter 1, that would be your weights. Chapter 2, %, 10%, 25, no, 30, and 20. So you can add up, you can see that 1.4 and 2.1 and 2.3 are going to be your high notes. That's where we're going to be talking about that's where your weights are going to be on your test. So let's go and talk about functions, because functions, and I'm just going to go back to, what page does 1.1 start on, so I can just go right back to it. What page? 1? I don't know how the book is done. Okay, there it is. Functions. So let's go ahead and get started. And I will write on the board, and we will look at functions and what they mean. I'm going to put some drawings on the board. And I am not an artist, but I'll do the best I can. You don't have to draw this. You can just draw a box if you want to. There's something going on with this computer. This thing's shaking. I'm not shaking. It's shaking. It's not writing correctly. All right. Now that's a picture of something. Some of you might be able to tell what it is, but they used to be on each floor of a hotel. What were they? Ice machine. All right. And we'll put ice machine for people that don't know what it looks like. What's moving? The projector or the movie suit? I guess it's just me. Maybe it's my eyes moving. Now, in order for an ice machine to work, it has to have electricity. I know that. Okay, let's say that the electricity is given. What do you have to have for an ice machine to work? Now, let's say that the ice machine works good, and let's say that it's plugged in and it's working good. Water. So, here's our water. And if the ice machine is working correctly, it takes that water, and what does it turn it into? Ice. Now, let's go back and let's say that I want to be experimental with my ice machine. And it works fine. The ice machine works great. And I want to put in Kool-Aid. I like strawberry Kool-Aid or cherry Kool-Aid. Let's say that I hook up a tank out here, and this tank holds 10 gallons of water. And instead of putting in 10 gallons of water, I put in 10 gallons of water, sugar, and Kool-Aid. What will happen? That's not rhetorical. I'm asking. What comes out? What will come out? It'll be what? What will it be? It'll be ice, right? But it won't be just ice. It will be Kool-Aid ice. All right? But how many gallons of ice will you have? You'll have 10 gallons worth of cherry Kool-Aid ice. Or strawberry Kool-Aid ice. I'm a great cherry strawberry person. Don't put no lemonade in there. Only thing lemon is worth being in is sweet tea. That's it. And cleaners. All my cleaners in my house are lemon scented because I like lemon scented stuff.
So that makes liquid ice.
Yeah. Mm-hmm.
I thought when you said ice, I thought you were like talking about like an ice box, like pre-refrigerator.
Yeah, up in the top. Well, the same thing. It makes ice. Either one. All right. Now a lot of you are saying, what the hell is he talking about? We're supposed to be talking about function. We are talking about function. Here's the function right here. What is this? What is the water, but what is it to the function? This is called input. And this is called output. Well, I can't get anything past y'all. Y'all are tight. Output. Input is the water. Output is the what? The ice. What's dependent upon what? Exactly. If I put 10 gallons of water in the ice machine, I'm going to get 10 gallons of ice. If I put 2 gallons of water in the ice machine, I'm going to get 2 gallons of ice. If I put 1 cup of water in the ice machine, I'm going to get 1 cup of ice. It doesn't work the other way around. I want 5 gallons of ice, so I'm going to put in 2 gallons of water. Doesn't work that way. The output is dependent upon the what? What else can we say? What else is the input in a function? Think of algebra. What do we input into a function? And what do we output? That's not rhetorical. Let me just write an equation up here. Y is equal to 2x plus 3.
What, you want us to title these notes as something?
Functions. Here's my equation in algebra. What do we put in? Don't have that algebra before. Now, what do we put into? Do we put x into it, or do we put y into it? We put x into it, right? And what do we get when we put x into an equation? We get y. So which one's which? There you go. I tell you what. X is the input. Y is the what? There's one more thing that we can add in respects to x and y. Starts with a D. I said it a while ago. When people say it's territory. My territory, or my what? Domain. Sorry about that. You're not supposed to have a heart attack or anything. Thought it was down. Your input. North Kakalaki. I have no idea who's calling me from North Kakalaki. Okay. Alright, input. X, domain. All of these things over here represent the input of a. That phone's going to ring again because it comes up on me. Better turn it down. And what is the alternate of the domain? And that's over here. The range is the counterpart to the domain. So let's do some review. Water is what? Input. Input is X. X is domain. Output is the ice. Output is the Y. Output is the range. All right, let's do another example. Alright, what is that? The bicycle. Alright, the reason you know it's not a motorcycle is because it has pedals. Do not make fun of my drawing unless you want to draw it yourself. Okay? Now, what's the input of a bicycle? Well, in order to ride a bicycle, a regular bicycle, you got to have two what? Legs. You don't have two legs, you're going to fall down. Alright? And that's not being insensitive, it's just a plain fact of gravity. That's why we have bicycles for people that can't ride a bicycle. They use their hands, or they use a wheelchair, or they use this thing that got a chain that goes to, you know what I mean, okay? So I'm not being insensitive, I'm just saying that if you try to get on a bicycle and you don't have any legs, you're going to fall down. So, what is the input? Your leg power. Your leg power turns the pedals, this gear turns this gear, and that causes motion. Your leg power is your what? Input, your X, your domain. Your out motion is your output, your Y, your range. Let me ask you a question. If you want to go faster on the bicycle, what does your legs do? They pump harder. If you want to go slower, your legs pump slower, pump not so hard. Okay? So the motion of the bicycle, what? Depends on what? The leg strength or the leg power. Again, output depends on what? Y depends on, and range depends on domain. Another example. This one I really have to look hard for. Okay? Well, it's the best I can do right now. Okay. And got a tractor in front of it. So some of you might know what that looks like. You know what that looks like? Stand far enough back. Close. Hay baler. Okay? You know, the hay bale comes out back here. But that's good enough. I'm not a drawer, so you'll just hay baler. I guess I should spend more time on baling, drawing a round baler instead of a square baler. But that's a square baler, all right? I hardly ever use one anymore because you can't get nobody to help you pick it up. You have to do it yourself. But anyway, what goes into the hay baler? Hay. And what comes out of the hay baler? A hay baler. Now, let's see how smart you are. What's the difference between straw and hay?
I've always wondered that.
You always wondered? Well, you're fixing
I
to
knew
find
there's
out.
straw, some-
I'm fixing to tell you. Anybody know?
Hey, straw is sturdier.
No? I figured you would know. Anybody know? Straw is the stem with the head cut off. It has no value whatsoever, hardly. Unless you, and straw is usually the byproduct of a harvest. I'll give you an example. And I like to teach things besides math. Here is a stalk of wheat. All right, there's a stalk of wheat. Here's a stalk of fescue. Fescue is real small. And here's a stalk of oats. Oats hang down. They look like little teardrops hanging down. All right, now if I cut this green, I can't spell green. If I cut it green and I leave and I cut it right here and I let it lay down and the seeds are still on it, that's called hay. Okay? If I let it get gold or let it get dry and I cut the heads off of it with a combine, what's thrown out is this. This is thrown out of the combine. And they're in windrows behind the combine like this. And the combine is a big old combine. I ain't even going to try to draw it. It's a big old thing. You don't see many around here. There's only about 3 or 4 people that's got one. We got one, but it's in the barn. We never use it anymore. It's got a big old header on it like this. And it's usually a John Deere. Well, anyway. What's left after you cut the heads off is nothing but the stem. And it's for straw. Straw is used for 2 purposes. Anybody know what they are? Nope. Huh? Gardening. You put it down for bedding or gardening, or, well, that's both of them. Bedding, and you put it down for, like, if you put seed out, like grass seed, the hay keeps the wind from blowing the seed out. And when the hay gets wet, it weights it down, so that way it won't, blow away. So straw really is, it's like a cracker to a starving man. They'll eat it, and they'll chew on it, but it has no protein value, it has no energy value. That does. And when it's green, and that's why you got to do it at the dough stage. What's the dough stage? Anybody know? It's when you pinch the seed, and it comes out like milk. It's white. That's when you're supposed to cut it down for hay. So if you wait any later, it turns into seeds, and that's when you don't want it. Same thing with corn. Corn, when you pinch corn, it'll pop out like milk. You don't want to wait later because then it'll turn into mule corn, which is what cows and mules eat. It's the hard as a rock. Okay, like your popcorn. That's what. Okay, now you learned a little bit about that. I have no idea why I got onto that, but anyway, now you know the difference between straw. And I'm going to teach you the difference between a silo and a grain bin also, because that's a very, people don't know that either. But anyway, I think it's very important that you learn stuff like that, because you don't want to make a fool out of yourself one day walking in somewhere or see a picture or something and say, oh, there's a silo. And somebody in there that actually knows what a farm is, they go, ain't no dang silo, you're stupid. I don't want that to happen to you. Because farmers do make fun of people that don't know about farm stuff. I'll just go ahead and tell you that right now.
So you probably do know Ernie?
Ernie who?
Maybe.
Ernie Major? I know probably his mother. Or is he up around 6 and 20?
No, it's got it's in Bloomingdale.
About 25.
It's Brady Major's Major Farm.
I've heard of them, yes.
That's what
Yeah, I don't know. I'm trying to think of too many things. All the farmers I know are out this area. But I've heard of the dangers. Okay. What was I talking about? Oh, hay. Now, let me ask you something. If I don't hardly have any hay, then how many bales am I going to put out? If my windrow looks like this, and there's nothing in that windrow but a little bit of hay, how many bales am I going to get? Not many. But if my windrow looks like this, and I've got a lot of hay in there, then what am I going to get? I'm going to get a lot of hay bales. Okay? So again, your input is the hay, and the hay bale is your output, meaning your Y or your range. And again, no matter what depends on what? The Y always depends on the X. So which one is the dependent variable and which one is the independent variable? Y is always dependent. Write that down. Y is always dependent. Y is always dependent. Therefore, Y is always Wally. What does Wally mean? Always dependent. So if Y is always dependent, what is X? Always independent. Now that's going to carry over into your sciences, especially in physics and chemistry. So they always ask, which one's the dependent variable? Which one's the dependent variable? Well, let me ask you a question. If I give you W is equal to 4 times 4s plus 2. Oh, I'm just making it up. Which one's the independent variable? Which one's the dependent variable? What? Good, because this one is in the what position? X position. You can rewrite this as Y is equal to 4x plus 2. So this one is independent, and W, or W, depending on where you're from, is dependent. And see, that's why students get confused in science. How did you know that that variable was dependent? How did you know that that variable was independent? Because you put it in form of Y and X, and you see which one's dependent and which one's not. Okay? So if you didn't learn anything out of class today, at least you learned this. Now, what are functions? Well, now I'm going to translate. I'm not going to draw this one because I don't have to. You've got your hay baler, your ice machine, you've got your bicycle, and you've got your hay baler. So now let's translate that into algebra. There's our function, 2x plus 4. Now I didn't put the y's in front of it because I don't want you to confuse the y as the function. This is the actual function. That's your hay baler, that's your bicycle, That's your ice machine. Now what are your values that go into it? X. Now, values. Okay? Values. Now, in this case, I'm only going to give you 5. Okay? 5 values. -2, -1, 0, 1, and 2. Now, I want you to give me my y values. Go ahead and do that. Shouldn't be hard. All of you have had algebra 1 and 2. So, what's -2 times 2? -4 plus 4? I think that accidentally hit the, yeah. That's supposed to be a 0, sorry. Yeah. What's -1 times 2? Plus 4? With positive 4. That. Positive 2. 0 times 2 plus 4. 1 times 2. 2 plus 4. 2 times 2 is 4 plus 4 is, what's my domain? -2 to what? Positive 2. How do you write that? Right now, let's go. Domain equals -2 to positive 2. This is called interval notation. And that's what most algebra teachers use. So what is my range? Range is equal to 0 to what? To 8. Now tell me what's so hard about that. You would be surprised, out of all the things in algebra, factoring, word problems, and domain and range is the hardest thing for students to get. And it's not difficult. Now, the reason it's not difficult with this one is the teacher manipulated the domain. How did I manipulate the domain? I told you that you could only use what? -2 to positive 2. And that's the only time, there's 3 times that the domain is affected. Right now. 3 things that affect the domain. And those 3 things are teacher / instructions. In other words, What is the range of the function if the domain is -2 to 5? Okay? Whether it be a test, or whether it be in class, or whether it be on homework, if it says that the domain is -2 to 5, your domain has just been manipulated. So that means your range will be manipulated. It'll be dependent upon the domain. 2, or B. If you have a complex rational function, f of x, or y, is equal to 1 over x minus 1. That is a complex rational function, meaning that you have a fraction in your problem. Why would that be a problem? Why would the domain be affected there without directions? Well, not the bottom's negative, but the bottom can produce what number that will not work? 0. And you can't have 0 in the what? So you can use all real numbers except for what? 1. Because 1 minus 1 will give you what? 0. So you need to make a note of that. Now we'll get to it later. We're going to explain it later. But I want you to make a mental note of it or write it down, because you need to remember it when we go back over it. You can't have 0 in the denominator. So therefore, x cannot equal 1. 0, bless you, cannot be in denominator. Therefore, x cannot equal 1. You can use any number in the world, but you cannot use 1. And therefore your domain is your domain is not all real numbers now. Your domain is all real numbers except x cannot equal 1. And the third type problem is a radical function. F of x is equal to the square root of x minus 1. Now I want you to look at the square root of x minus 1, and I want you to think of what numbers will or will not work in that function. Just take about a minute and just think about it. Don't say nothing. Just think or meditate on what numbers will work and not work. Thanks. I don't know where I got that away. Another shirt for the farm. What's this thing? I'm a loser. Okay. Now, like I said before, in pre-algebra, you were taught y is equal to x plus 2. And then over here on the right here, x plus 2 plus x minus 6, you were told to distribute and add like terms, and you would get that. Now, oh, I'm sorry. Now it gives you f of x is equal to x plus 2, and g of x is equal to x minus 6. And now you're supposed to find f plus g of x. Well, guess what you do? You do the same thing that you did back in pre-algebra. X plus x is 2x. And plus 2 minus 6 is what? And what did we get before? Same answer. You'd be surprised on how many people go through algebra. They get to the functions and they can't even do the problems that they were doing 6-8 weeks before in pre-algebra. It's the same stuff. Just a fancy way of writing y is what it is. All right? Here we have x plus 2 minus x minus 6. F minus g of x. This minus this. X plus 2 minus x minus 6. Positive 1 is distributed. That negative 1 is distributed. You get x plus 2 minus x plus 6. And what do we get? 8. Let's look back and see what we got in pre-algebra. And then they say, well, we want f times g of x. Well, that's x plus 2 times x minus 6. And what do we use now? FOIL, which would be x squared minus 4x minus 12. Minus 12, sorry. X squared minus 4x minus 12. X squared minus 4x minus 12. Now, I'm not going to cover division because you don't see it very much. No, not that. What was f of x? F of x is equal to x plus 2 or x minus 2? X plus 2. And g of x is equal to x minus 6. F divided by g of x would be x plus 2 over x minus 6. Can you do anything with that? No. That's why I usually don't do division too much. It's the same thing. You don't do anything. You see it. Now let's do composed. And that's where we start the lesson after I did the review. Composition of functions. Composition of functions. It is another word for substitution. Now, let me talk a little bit about this representation right here. I'm going to go to another page, and you can go to another page in your book, or you can just go over somewhere else and write it, but it's going to be a good bit of information. When you see this f of x is equal to blah, 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 this x right here, or whatever it is in the parentheses, whatever is in parentheses needs to be plugged in to the function. Okay, now you need to highlight that. You need to put a dot around, a circle around it, or do something. Huh? I don't know if it's in the book. It's not written like this, I can guarantee you. Because this is a Hebraism. Whatever is in parentheses needs to be plugged in. Okay? Is it? You're supposed to tell me. Thanks a lot. Appreciate it.